Hello everyone. This video will be on chapters 7 and 8 of the book Extending Children's Mathematics, Fractions and Decimals by Susan B. Emson and Linda Levy. In the previous chapters, we have learned how important it is for students to use their own strategies when learning certain mathematical concepts. As chapter 7 begins, we explore the importance of students using their prior knowledge of base 10 and fractions to understand decimals. Throughout this book, students have been using various problems such as multiple groups problems, equal sharing problems, and relational thinking in order to solve various math problems. In Chapter 7, the first type of problem that is introduced is a base 10 problem. This word problem is very similar to multiple group problems. As seen on the screen, the problem reads, Susan has 8 bags with 10 marbles in each. How many marbles does Susan have? This example is a multiplication problem with 10 in a group. In order for students to know how to solve this, students need to understand that numbers can be made up of groups of 10. This is usually seen in the earlier grades when students are counting the number of days that they have been in school. Many teachers introduce base 10 using straws and counting them by bundles of 10. When teachers look into the upper grades, they can introduce and have students practice base 10 problems by using multiplication and measurement division problems. For these types of problems, there are not 10 in a group, but rather positive powers of 10. For example, the Crystal Clear Company sells water in 10-gallon bottles for water coolers. If they pump 57,000 gallons of water, how many bottles can they fill? These types of problems, like explained in other chapters of this book, give the students a chance to use relational thinking in order to solve, as well as discuss their strategies with their friends. In Chapter 7, a teacher with a 4th and 5th grade class is looked at. She reminds students to think before they continue with certain problems. She asks the students to decide what the problem type is and to think relationally about the problem. Miss Andrews breaks the class into 4 groups and was interested to formally assess around the room and check for understanding. She shows the importance of offering conceptual tasks to her students. Miss Andrews' approach was encouraging students to use their knowledge of base 10 with their understanding and knowledge of fractions in order to understand decimals. She uses multiple groups problems as well in order to build understanding of base 10s. The interesting strategy that Miss Andrews used was she did not group her students based on ability, but rather she differentiated during whole group instruction. Once Miss Andrews saw that the students were understanding the concept of decimals using multiple groups problems, she moved on to open number sentences. She did not ask for the students to do this individually, but they did it as a whole class so that the students could see the process. Afterwards, Miss Andrews put the problem on the screen. Find 3 solutions that will make this number sentence true. A times 10 plus B equals 87. Students were not used to solving these problems with more than one answer, so these were more challenging to our groups. After she saw that some students were not decomposing the numbers correctly, she knew she had to teach more lessons on open number sentences. After the lessons were taught, the students were able to decompose numbers in base 10 units. Miss Andrews moved on to decimal notation. She explained to her students that fractions with a denominator of 10 could be written with a decimal point. After students were able to think relationally about decimals, Miss Andrews found that her students were able to add and subtract them easily. For example, she gave them the problem 8 plus 0.3 plus 1.02 equals m. Students were all able to answer this quickly and correctly. Miss Andrews focused for 6 weeks on decimals. In conclusion, students who understand fractions and base 10 numbers relationally can then move on to decimals and apply their strategies to solve problems involving decimals. In Chapter 8, we look deeper into teaching adding and subtracting fractions and decimals as well as multiplying and dividing them. When students are multiplying and dividing fractions and decimals, they are being asked to involve new conceptual challenges. When students are learning how to add and subtract fractions, they can use their understanding of equal sharing problems to solve them. This is especially true when the fractions have unlike denominators. When students are using equal sharing problems and multiple group problems, they are having the opportunity to combine like fractional units. The hardest part of adding and subtracting fractions for students is to find a common denominator where they have to find the least common multiple. However, some teachers introduce the standard algorithm to students for them to solve the problems. The standard algorithm for adding fractions is a over b plus c over d equals a times d plus c times b divided by b times d. When teachers are introducing multiplying and dividing fractions, they introduce partial groups problems. Later on, teachers introduce the standard algorithm to students, which interestingly enough is similar to relational thinking. It is stated in the book that students who develop relational thinking strategies to solve division of fraction problems before they learn the standard algorithm are better prepared to understand how it works and when to use it. Also, they extend their knowledge of fraction division and multiplication, and later on can solve algebra problems that involve multiplication and division. Like it was stated in the Pesach and Kirshner article, having students think relationally about mathematics will support them in the long run, where they will be able to develop proficiency in mathematics. There is a time and place to teach the standard algorithm, but many researchers have shared with us, as we have studied in our math class, how important it is for students to think and use their own strategies in order to solve problems. In the textbook Extending Children's Mathematics, Fractions and Decimals, we have learned a lot about the importance of involving students while teaching mathematics. It is important for us as teachers to allow the time for our students to understand and not give them the answers, but rather have them solve them as they relationally think about the problem in front of them. I have learned a lot reading these chapters, and I hope you have as well. See you next time.